A teacher surveys their students to find out if they have eaten at the local Thai and Indian cafes. The results of the survey are shown in the following Venn diagram. So here are the two sets. Let's say T, big T for Thai cafe, I for Indian cafe. Write down the number of students surveyed. All we have to do in this case is to add these four numbers. The number of students surveyed is going to be 10 plus 13 plus 8 plus 2, and this is equal to 33. There is a total of 33 students surveyed. Write down the number of students who have not eaten in the Indian cafe. The students that have eaten in the Indian cafe are inside this circle. So those that did not eat at the Indian cafe is a total of 12. So letter B, 12 is the number of students that have not eaten in the Indian cafe. For part C, a student is chosen at random from those surveyed. Find the probability that this student has eaten at both the Thai cafe and Indian cafe. So the number of students that have eaten on both are the ones here in this region. So we have a total of 13 students that have eaten at both cafes. So 13 out of the total number of students, which is 33. So the probability required is 13 over 33. Let T be the event student has eaten at the Thai cafe. Let I be the event a student has eaten at the Indian cafe. Find probabilities that the probability of T union I. To do this, we have to remember the concept of union and intersection. If you have two sets, A and B, and you want to know the union of two sets is all the two sets together, including this region in the middle. The intersection is only in the region in the middle. Okay, so for this question, we want to find the probability of the union, but here we have these two cases are very important. Here we want the probability of T union I. So for this thing here, we consider that the probability of T union I is the number of students in the union, so these three parts together, which has 31 students. The total is 33, take away these two, so 31 is the students in the union out of a total of 33 students. So the probability of T union I is 31, the number in the union out of the total number of students, 33. And finally, E, state whether the events T and I are mutually exclusive. Justify your answer. So to remember the concept of mutually exclusive events, let's have a look at the formula booklet. The formula booklet has this information: mutually exclusive events. Probability of A union B is the probability of A plus the probability of B. This means that to be a case of mutually exclusive events, the intersection must be equal to 0. The formula above, combined events, is exactly the same formula, but with minus probability of A intersection B. In the case of mutually exclusive events, there is no intersection. A diagram to represent mutually exclusive events would be a diagram in which we would have no intersection between the sets. So that's not the case here. So that's why it's not mutually it's not a case of mutually exclusive events. So here the intersection is not 0, is not the empty set. Since the intersection is different from the empty set, we can say that T and I are not mutually exclusive. Mutually exclusive events.